Hi, everybody. My name is Abby Rogers, and I'll be facilitating this webinar on electronics manufacturing facilities and humidification for them. There will be a survey distributed at the end of the webinar in the thank you email. Please make sure to take that survey, as your feedback is very important to us. We will also be distributing a handout with the presentation, a PDF version of the presentation with that thank you email. And then a recording of the webinar will be sent out to all registrants. So at the end of once that webinar recording is done, it'll be sent out later this afternoon. And with that, we will take questions at the end of the session. And I will now pass this on to Ryan.
Thank you, Abby. Good morning, everyone. And I guess as we're listening to on-demand webinars, welcome. I am Ryan Reimer, one of the dry steam product managers. And with that, we'll get started. So today we're going to be talking about electronics manufacturing and the facilities around the climate control aspects, and really focusing in on how humidification can help increase productivity and eliminate unnecessary waste. So an overview of this morning's curriculum is really defining what do we mean by electronics manufacturing. What are the reasons that these electronics manufacturings, or you as yourself, may consider humidification control and what to consider? System considerations, things along the lines of, where do I place stuff? What other components are in there to really make a complete system? Then moving into humidification equipment itself, looking at the energy impact that these facilities have to maintain throughout their, obviously, product processes, and how humidification plays a role in that, whether we talk about adiabatic or isothermal. Talking a little bit about redundancy as we talk about operations of these facilities tend to be 24/7. Water treatment as it relates to humidification and maintenance, and then just a conclusion at the end. So electronics manufacturing is really the production of electronic components, anywhere from the design, manufacturing, and testing, as well as distributing into the end user system or an OEM piece of equipment. These types of things could be anywhere from, our Vapor Logic board being manufactured for our Vapor Logic controller, or your phones that you probably have in your hands, and then, obviously television screens, electronics, and automobiles, etc. So really there's, multiple different processes as it relates to electronics. I picked a couple just to define, there's many steps, PCB or printed circuit board, processing, or wafer processing, or even surface mount technologies and SMT. Looking at those different processes where they'll have a conductive material and an insulating material, and obviously layers and different components and different processes. So the thing I really wanted to point out here as we go through this and we get later on into the adiabatic solutions is a lot of these processes listed can be quite energy intensive in themselves and generate heat as an inefficiency of that process. So looking at environmental control factors, the one that we're focusing in on today and is underlined and colored / bolded is humidity. But it's not just humidity that matters to these facilities and to you as end users. Really, it's the total package, and humidity and temperature are so intertwined that we're going to be talking about those both as we talk about controllability. Air change rate is another high topic, and really depends on the type of facility you're running. What classification that may be. If it's a class 5 or 6, which would be a higher end, typically like an aerospace application, versus a normal class 7 or 8 has less air changes per hour, which a majority of electronics manufacturing fall into. And then contamination, particulate filtration. Even though humidification equipment itself isn't physically filtering that particle that may be a contaminant, it's really interacting within that air to provide weight or mass to that particle from a moisture perspective. So when we talk about keeping the relative humidity between 45 and 55, that's really process dependent. And as you look at your different systems in your facility, from different manufacturers, they might have different control ranges. An example that would be less than that would be a photolithographic process, which I believe is typically 35 to 45% RH. But once we get in that control range, and once that's been established for a facility, these types of facilities usually have tight control regarding what I mean by that, plus or minus 2% RH. Roughly, to maintain that would be about a 0.9 degree F dew point control. So really, once you've established what you need, tight control is obviously important for consistent stability. But what this does, why, once you've determined that you need RH, you need relative humidity and moisture in the air, it does a few different things for the facility. Talking about indoor air quality, as we have people that work on these processes, manufacturing processes themselves, whether that's the soldering step, whether that's printing circuits. And obviously, there's two ends of the spectrum when we talk about the process. Too low, obviously we're at risk for electrostatic discharge, which is the next bullet point. If we go too high, if we have too much moisture, either naturally or we overshoot with humidification equipment, is potential corrosion on different metals in the process. Another thing when we have good control is preserving materials and furnishings, and then improved comfort for the building occupants. The other thing in a subcategory of humidification equipment is the adiabatic section that provides sensible cooling. So we have this large heat load in a building from the process equipment, and can we benefit from sensible cooling is really that last bullet point. And we'll go a little further in depth in that. And obviously I want to preface each application has different goals in mind. So maybe adiabatic is not the solution, or maybe you want an isothermal solution for one reason or another, and we'll jump into that. So issues caused by low or fluctuating relative humidity is really the damage that electrostatic discharge can create when we're not within a specifiable range. When we talk about ESD, it's 30 to 70% is that recommendation. So it's a really broader range. Just like that human occupancy is different than that process range given. So if we talk about human health, 40 to 60% RH, okay, so now we're starting to narrow that scope. This is just one aspect of what that final RH percentage set point may be. If we're in an uncontrolled environment, high humidity, I mentioned this briefly, is condensation on cooler pieces of equipment in there. And then obviously the outcome of that is rust and corrosion. Obviously not advisable. That's product loss. That's essentially hitting the bottom dollar for these facilities. Material instability. So with soldering process in particular, having a low humidity can compromise that integrity of that joint. And it's really, when we want integrity, we really want to make sure that we're having batch stability and reduce that scrap. That's really the goal of humidity in these types of environments. Is it's process driven. It's obviously that process piece of equipment, but also that end product and having that stability. So really understanding what process you're printing on, if it's a wafer board or if it's a flexible type material for, a sensor, for example, those may have different material requirements and typically relate back to RH. So having that fluctuation, and this really comes back to process control, is if we're at steady state, we want to make sure that we are at steady state with RH and temperature can influence that. So if we fluctuate, we can obviously cause damage to components from expansion and contraction. And we want to do our best to mitigate that risk. Process equipment failures. So within these designs themselves, if it's a soldering machine or if it's a drying machine and you want to control that RH at a regulated pace, that's something that's within the design of that piece of equipment. So if you look at the specific piece, that could potentially tell you where you need to be within. Dust and raw material buildup to static. So again, back to having that humidity and getting that air particulate out of the air can help with your quality. The other piece to this, and this is product by product, but the environmental control within these facilities. A lot of OEMs of these different machines will require certain temperature ranges, certain filtration, certain humidity, and we want to make sure we're within that range that they specify. Production and quality, again, that fluctuating or low or high relative humidity really can destroy some batches, and you have to scrap, which can obviously be very costly. I mentioned earlier regarding the tolerance or the controllability within plus or minus 2% is something very typical. I've seen as well, depending on with good dry bulb control, 2.5–3% as well. And obviously going the other direction, certain instances require plus or minus 1%. With this, since this is such a high criticality, I do have another slide on redundancy for certain processes. So if that's a redundant humidifier, for example, just so we have that control, I'll talk about that in a few slides. And lastly, these aren't factories and facilities and clean rooms and things that aren't without human occupants. So having a comfortable and healthy environment is something that can really help or hurt the bottom line with dry, cracked skin, eye irritants, or even influenza or other viruses. Going back to the Sterling chart, that could be propagated by ranges outside of 40 to 60% RH. So diving into some considerations with this, we're talking about a high-level process control that we want to make sure our final product is going to meet specification and go through testing and inspection and quality measures at our end users. So the first piece is, where do you put your humidity sensor? Do you put it right next to the critical piece of equipment? Do you put it in the duct? Really, you don't want to put it next to cold walls. You want to avoid sunlight because those things can interrupt that flow. And also, if you're doing an in-space type application where your humidifier is putting that moisture into the space, you don't want to spray, whether that's liquid droplets from high pressure atomization or even isothermal steam, where that sensor may be directly in front of a nozzle or directly in front of an SDU. That would give some false positive things that we want to eliminate. Understanding high limit duct RH sensors, where you may choose a switch or you may choose a transducer. And really the best practice is to get it as far downstream of that dispersion unit itself. And that's in an ideal world. We understand that 8 to 12 feet downstream might not be possible, but really the best advice is get it as far down as you possibly can, in obviously a homogeneous mixture of that air to give a good representation of that value. Also, if that's true about switches or modulating high limits, but if we want even more control, the modulating high limit would be one step further than the switch. And then communication. With all of these processes, there's a lot to think about in these facilities. And one piece is communicating back to a building automation system or building management system to really give you functionality of, tell you alarms and tell you the status of your equipment. This is a critical piece of equipment as we talk about the environment and how well that final product will come out. And then communicating that interface in a more extravagant or actual result would be communication interfaces versus an analog or a contact signal. So things like BACnet or Modbus would be quite common in this space. So jumping into types of humidification, now that we've talked about why should we humidify these types of spaces, really understanding the two breakouts from a high level perspective. To be fair, I've seen both isothermal and adiabatic technologies. I've seen anywhere from technology, from the isothermal side of electrode style, which would be Dry Steam's XT series, or an RTS series, or vapor mist, vapor stream. And it really comes down to the goals of that facility regarding which type they go to from a controllability perspective and utility source. But going back a step, talking about what is isothermal. The isothermal side of things is boiling water. The picture on the right depicts what most people have seen is a tea kettle on a stove or on a fire, and taking that heat and heating that water directly. Then when that dry steam, hopefully, is coming out of that unit, then it's readily absorbed into the air. Likewise, the other flip side of that coin is adiabatic solutions. We're still taking energy, but we're taking energy from the air itself. So we'll see that, the sensible cooling or, your sensible heat as depicted on the slide will decrease during these processes, which can be beneficial for mechanical cooling offset. And so instead of boiling the water, we're going to distribute this, if it's high pressure atomization, into a readily absorbed liquid aerosol, essentially, and have that air meet the contact with the water and evaporate. Wetted media, evaporative media solutions will have a surface, which is the media surface, that will allow that heat transfer to take place. Ultrasonic is another technology in this space for adiabatic, where it's creating a really fine mist or fog that will use that energy in the air. The piece at the bottom regarding free cooling, there's many ways to look at this. If you're able to evaporate water, every pound evaporated is 1,000 BTUs removed for the air. Another way to put this is if we're looking at tonnage, at cooling tonnage, every 12 pounds per hour evaporated can lead to an offset of 1 ton of cooling. We're not going to get super into the psychrometrics of this. Obviously, you have to have that differential of RH available to get that cooling. If you're already at set point, you're not getting any cooling from that piece of equipment because it won't be running. So in this space, really looking at commercial grade or industrial grade humidification equipment, this isn't something that, you go to Target or down to the Home Depot and just get one to put on the tabletop when we talk about these tight controls. So looking at a partner like Dry Steam, having that commercial grade humidification to really tweak in and give that best fit. So looking at features of, if that's gas to steam, or you want insulated tubes, or you want redundancy within that same system, that's something that a little tabletop unit is not obviously going to perform well on, at least as we talk about controllability. We really want to be not too high and not too low. The other piece when we look at commercial grade or industrial grade humidification equipment is what kind of literature goes along with this and support goes along with this. So we're not a company, and none of our sales reps, at least to my knowledge, are consultants that write IQ, OQ, and PQ processes for a specific company. But if that is something that if that facility requires it, our documentation can obviously go to those consultants and give that type of information, whether that's wiring diagrams, that's process and instrumentation diagrams, and how we operate that piece of equipment, and really goes into the nitty gritty of obviously vapor logic and how does multi-tank work for redundancy, those kinds of things. So then they can qualify that operationally. So when they go through that test procedure in the future, after working with an outside consultant, most likely, that there's documentation there from us, more so than just a 2-page manual or something like that. So energy. Energy is a big deal in this sector, and they're really a large energy user. Just from the processes themselves, there's a lot of heating and cooling and different printing technologies and different things that generate waste heat that we could potentially benefit from with adiabatic solutions. So I listed printing machines, soldering, and then the inspection, whether that's optical inspection or a visual inspection or laser inspection, those types of things. Those pieces of equipment use utilities, and with that comes inefficiencies. Obviously, they designed to not have inefficiencies, but there's no 100% efficient solution. So when we look at energy, I previously mentioned that I've seen anywhere from isothermal to adiabatic, and it really depends on what your facility's goals are. I've seen adiabatic combined with isothermal in the sense of, okay, I want a majority of my load to be taken care of by high pressure atomization, for example, for that recirc air or incoming air, makeup air. And I want to do some trimming with an electric unit because the turn down is that much greater. So there's solutions like that to mix and match depending on the goal, where we get a bulk done, for example, with adiabatic because it's energy intensive, energy saving essentially, and where we want that fine tuning at that very specific spot with, let's say, an RTS, for example, resistive to steam unit. And not only does that electric utility matter from kilowatt hour perspective, but also the peak demand. These facilities use a large electrical load, and peak demand can be quite substantial and potential for savings. So operation around redundancy. So again, most facilities run production around 24/7 operation, and their critical applications just based on the environmental conditions required. So what do we do to help those kind of customers maintain a high level of quality and set point around RH? Well, some of those answers are redundant systems, anywhere from depending on system type, N+1, 2N, 2 parentheses N+1. Looking at those different control schemes, and obviously it's product dependent, depending on which control scheme you want to do. But there's options here at Dry Steam where we can really tailor that need for you. The first depiction on the screen is a high pressure atomization pump station, where within that it's essentially an N+1 depiction for that pump station, for the pump itself. Excuse me. On the right side, we got examples of electric resistive units along with gas to steam. And that's a way you can do, the redundancy regarding, multi-tank control for the vapor mist in this case. And then the larger load of GTS. So I talked about the example of a high pressure atomization for a bulk majority of the load, and then a trim humidifier for that tight control with a resistive unit. This is 2 isothermal, where the GTS will give, gas to steam will give the high load, and then really that tweaking of that load would be by the electric resistive. The biggest thing is our product, a humidifier, its main ingredient is water coming in. So kind of talking about what do we want to do if we're talking about 24/7 operation, and we're talking about uptime criticality. Water treatment plays a very large part in this. There's dissolved solids, and there's a whole presentation. So I'm going to give the short condensed version. There's whole presentations on water treatment in our library. But if this is the main source of water and there's dissolved solids in there that can cause scale or corrosion, obviously scale and corrosion are bad as it relates to uptime. They can be taken care of either on the back end with maintenance, whether that's chemical cleaning or physically chiseling or removing that scale. But the thing we see in this market is they don't seem to shy away from water treatment, high quality, willing to pay, for that high-end solution. And water treatment, specifically reverse osmosis, removes 98% of that total dissolved solids. And even one step further, deionization of that water, removing that last 2% that the RO cannot remove on its own, just through its own process design. So looking at water quality is important, not only from that, but within these humidifiers, there's a scale management, essentially, or cycles of concentration. If we can eliminate how much total dissolved solids in there, that will decrease our draining frequency. If we decrease our draining frequency, that means less refill, less potential for, less potential for quenching that boil. So really thinking about cleaner water equals more uptime. And then the second question is, obviously I mentioned reverse osmosis systems, other pre-treatment like softening systems to keep that RO up longer and for longer periods of time between maintenance is something that should be considered. So coming up on the end of the presentation here, one of the things that is kind of a call to action is a site survey. If you don't know what your humidity is in your facility, the best thing to do is go check and see, are you within that range? You can use a hygrometer, or if you have RH transmitters in your facility, that's something you can go look at, target data and trend data, essentially. So at that target of 50%, just from picking a singular point within that range, if you're seeing lower than that, if there is a humidifier, check to see if it's operating. If there's no humidifier, then obviously contact a local sales representative of Dry Steam, and we'll come help explore options to understand your layout, your goals, your capacities, what you're really looking to get out of from humidification control. Looks like I skipped a bullet point. If it was below your target set point for controlled, adjust or raise the set point. And then lastly, manage your building envelope for condensation control. So thinking about things like space pressure control, your air duct leakage, if there's any thermal breaks, and then, power source, etc. Regarding that site survey. Where are you physically going to put that piece of equipment? Are you going to do it in space or in an air handler or duct? So things like that can be beneficial from a site survey. So in conclusion, really the main goal was to eliminate unnecessary waste and increase productivity. That's something, humidification plays a big role into as we talk about total environment control. This is one piece of that. And really within this highly competitive market, especially, and with the supply chain, as much as I hear that they're alleviating supply chain issues as we go, is really humidification can be the simple solution to really maintaining your environment and thusly affecting your process and product. So with that, I will open it up for questions.
And keep in mind that you can ask questions using the question tab in the left control panel. And we'll just wait for a few minutes for any of those to come in.
As we're waiting, I guess before people start dropping off, thank you for coming today and listening to this presentation. And hopefully there was a good takeaway or two for you as we talk about electronics manufacturing.
All right, Ryan, I don't see any questions coming in, so looks like we can end this session. Remember, anybody that's still on, that a survey will be distributed along with a PDF version of the presentation and a recording of the presentation after we close out of this. And thank you again for joining us.